Figure 1 shows part of the graph y equals f of x, where x is a real number. The graph consists of two line segments which meet at the point 1a, where a is less than 0. One line meets the x-axis of 3, 0, the other meets the x-axis at the point minus 1, 0. And the y-axis at 0b, where b is less than 0. Given that f of x is equal to the modulus of x minus 1 minus 2, find the value of a and the value of b. Okay, so for the value of a, I know at this point here that x is 1, y is a. So if I substitute that in to the function, x is 1, y is a, I'll get a is equal to the modulus of 1 minus 1 minus 2. Excuse me. 1 minus 1 is 0. The modulus of 0 is 0. So therefore a is minus 2. Now to work out the value of b, or b is the y-intercept here. That's the coordinates where y is b and x is 0. So if I put b in, oops, if I put b instead of y and 0 instead of x, that's going to give me the equation b equals the modulus of 0 minus 1 minus 2, excuse me. 0 minus 1 is minus 1. The modulus of minus 1 is plus 1. So 1 minus 2 is minus 1. So there we go. I have worked out that a is minus 2 and I've worked out that b is minus 1. Let's move to part D of this question, or second part of this question. We need to find the value of x for which f of x is equal to 5x. So when is my function, when is the graph equal to 5x? Well, 5x, I know that goes through the origin, and it's got a gradient of 5. So it's going to look something like that. I know for certain that it is steeper than the function f of x. I know that it's only going to intersect f of x in one place here. I know for a fact that it will not intersect, this line here is not going to intersect with this curve over here at all. Sorry, not the function f of x at all. They're not going to intersect because f of x has got a gradient of 1. It's a 1x here. Every time I go along one, I go up 1. Whereas the blue line has got a gradient of 5. So that's important because I know that I'm only looking for one solution here. I also know that that solution is the part of the graph, part of the modulus graph that was affected by the modulus, that did get flipped, that did get multiplied by minus 1. So when I come to solve this equation, I'll have my 5x is equal to f of x, and the f of x is usually like this. But like I say, I know that this part of the graph was the bit of the graph where the modulus flipped it, so multiplied it by minus 1. I can now solve this equation. To find that 6x is going to equal minus 1, so x is equal to minus 1/6. And that's the answer to part D. Part E finds the values of k given that f of x is equal to half x plus k has two solutions. So half x plus k, what would that look like? It's got a y-intercept of k, I don't know what that is yet, and it's got a gradient of a half. So for example, it could, if this was k here, my line could look something like this. It's got a y-intercept of grey, it's got a y-intercept of k, it's got a gradient of a half. There would be two solutions. One solution here, another solution over here. So k, the graph could look like that. It could also, if k was perhaps here, then the graph could look like that. A y-intercept of k, gradient of a half, and there'd be no solutions. The key thing for me to think about when solving this question is the vertex of this graph. What's the value of k when the line goes through the vertex here? That's the key thing for me to think about. So, when does this line, a half x plus k, when does that pass through the vertex, which remember was the coordinate 1, minus 2? So let's see. Let's substitute that in. Let's substitute the minus 2 instead of the y, 1 instead of the x, and I find that k is minus 3 over 2. So what I'm saying is, if k was minus 3 over 2, there would be one solution to this equation because it would be going through the vertex. There'd be just one solution here. We want two solutions. So I'm saying that as long as k is bigger than minus 3 over 2, as long as I am looking above this y-intercept here, as long as k is above bigger than minus 3 over 2, then the line would either be like this, or like this, or like this, or like this. There would definitely be two solutions. So my answer is that k has to be greater than minus 3 over 2. Then there will be two solutions. So the key thing with those sorts of questions is always looking at the vertex, and you can then decide whether it is bigger than minus 3 over 2, equal to minus 3 over 2, or less than minus 3 over 2, depending on whether you want two solutions, one solution, or no solutions.